Hello everyone, this is the fourth video in the terminal course in which we'll talk about process management in the terminal. Last time we were looking into how to view and edit files. For that we had a fake server which only generated logs. We're going to use it again this time, but focus on how to manage this and other processes in the terminal. By the end of this video, you will have learned the difference between a foreground and background process, how to send processes to either the background or the foreground, how to find, suspend and kill a process, and a few useful terminal tricks. First of all, if you weren't with us last time, you can find a link to the needed file for this video in the description. You might need to change the file mode to be able to run it. Once you have the files, run this command. It will allow you to execute our fake server. Alright, now that we're all set, let's run the server. When we do it, there is nothing happening in the standard output. This is because our script doesn't do anything that renders data on the screen. But the thing is that you can't use this window when the process is running. That can be quite annoying, but there's a way out, even a few. First, we'll need to stop the process. You can do it by pressing Ctrl+C. Now it's not running. Let's run the script again. Another option would be suspending the process. You can do it by pressing Ctrl+Z. The terminal says the job is suspended. But what happened to the process? When a process running in the terminal is suspended, it gets paused and is placed into the background, not actively using any CPU resources and not processing any instructions. The process isn't terminated, so it can be resumed at a later time, either continuing in the background or returning to the foreground. If you want the process to be run in the background, you can run the bg command. As you can see, it's continued now. The terminal gives us the job ID, its status, that it's continued, and the name of the script. You can even bring it back to the foreground, the way it was when we ran the script for the first time. To do so, you can run the fg command. Nothing happened really, but I can't use the terminal line anymore, meaning that the script is running in the foreground now. Alright, let's suspend it again by pressing Ctrl+Z. What if I forgot that I suspended an instance of my fake server and ran another one? Let's see. It's working. Then I suspend this one too. To see all my jobs, I can simply type jobs. On the left it says how many jobs have been suspended. If I need to send the first one to the foreground, I can use the fg command again with the job ID preceded by a %sign. It might be a little bit confusing because I'm using the words processes and jobs at the same time. To continue, we need to understand the difference between the two. A process is an instance of a running program. Every command you run in the terminal spawns a new process. Is a running fake server a process? Yes. Well, what's a job then? A job is essentially a process or group of processes that is initiated from a specific terminal session. Jobs are related to the shell session that were created from. Let's suspend the current process again. We should have a few suspended jobs by now. To see the list of jobs, type jobs. You can see all our jobs in this terminal session. Except for the job numbers assigned by the shell, there are also these plus and minus signs. The plus sign indicates the default job for the fg and bg commands when no job number is specified. This is so-called current job. So if I run the fg command, it will run the job that marked with a plus sign. The minus sign indicates the job that will become the current job if the current job is terminated. It's sometimes referred to as the previous job. Let's try. Ctrl+C to terminate it, fg again, and the current job is the job that was the minus job. Now, if you open a new terminal tab and type jobs, you won't see anything, because jobs are tied to the terminal session. And by opening a new terminal tab, we created a new terminal session. But wait, does it mean that we won't be able to suspend or terminate the jobs from the first session? No, we can, because those running scripts are still processes, and processes are identified by process IDs, which are unique across the system. However, when it comes to sending processes back to the foreground, it can be done in a different terminal session than the one it was started in. Since we can't bring the process back to the foreground in this session to suspend it with Ctrl+Z, we'll have to go another way. We can send it a signal. What is a signal? A signal is an asynchronous notification sent to a process to notify it that a specific event has occurred. In other words, we can ask a process to do something by sending it a signal. Let's suspend the process from the first session from within the second session. For that, we'll need to know the process ID. To find it, let's get back to the previous tab. The script is running in the foreground, so we'll need to suspend it to be able to use the command line. Process IDs are not shown by default, and to see them, I can type this. Let's copy this ID, bring the job back to the background, and go back. Now we can send a signal with the kill command. And nothing happened. But if we go back to the previous session, we see that the process has been suspended with a signal. There is a catch though. You can run this command multiple times, but there is no verbose option or feedback about the status of the signal delivery, unfortunately. Okay, what else can we do with processes? What are the signals we can send? Well, there are plenty of those, and they can potentially vary between different Unix-like operating systems. But don't worry, the most common will stay the same. Let's take a look at them. SIGINT interrupts the process. SIGKILL kills the process. SIGTERM asks the process to terminate gracefully. SIGSTOP suspends the process. SIGCONT continues a stop process. So if we want to continue a stop process, we can send it a SIGCONT signal. Now if we go back and run the jobs command, we'll see that the job is now running. Just to clarify, we could also do it from this terminal session too. When we want to kill a process, we send either a SIGINT, SIGKILL or SIGTERM signal. Let's try it. If you run it again, it won't work as there's no such process anymore. It's been terminated. Let's run our server again. If I now press Ctrl+C, it will send a SIGINT signal to the process. The final result is similar to sending a SIGKILL signal. The process has been terminated and thus we don't have it on our jobs list. Let's bring the last one to the background. Now we can terminate it by sending a SIGTERM signal. It's terminated now too. So what's the difference and what signal you should send? There are two things you need to know. First is that SIGINT and SIGTERM don't terminate processes, but ask them politely to terminate. It means that these signals can be caught by the process and perform some cleanup tasks. For example, releasing memory or removing temp files. Whereas the SIGKILL signal is harsh and terminates the process outright without regard for cleanup. It's usually used as a last resort when the process is not responding for some reason. Thus, prefer SIGINT or SIGTERM and use SIGKILL only when the first two didn't work. But what about SIGINT and SIGTERM? Although SIGINT can be sent programmatically using the kill command, it's semantically associated with an interactive user request. In other words, when you press Ctrl+C. Answering the question of which signal to send to gracefully terminate a process, use SIGTERM. Another thing that I mentioned earlier is that signals mostly can be caught. Note that SIGKILL can't be caught. What it means is not only that processes can perform cleanup tasks, but also you can even implement signal traps yourself to run commands before exiting. But we'll leave it for now as we'll get to it once we've got to shell scripting. Every signal has a numeric value. For example, you might encounter something like this. It's an alias to this command. If you're interested in learning those numeric values, you can take a look at them in the signals manual file. But watch out, as this command might not work on M-series MacBooks. Then you can check pkill instead. You might find yourself in a situation when you started multiple processes, maybe Node.js servers, in different terminal sessions and it's become hard to debug the system. You want to terminate all processes of your program. Going through all terminal sessions to find the PIDs is not an option and you want to do it quick. Let's reproduce this situation. To run a few instances of the fake server in the background, I'll use the background operator after the path of the script. Thus I can run multiple instances of my script without blocking the command line or pressing Ctrl+Z every time. This operation is called backgrounding. Every time I send a process to the background, I get its process ID. I can also find them if I run the job command, but that's if I'm in the same terminal session the processes were run. How do I find them if I'm in another tab? You can use pkill to look up processes based on the names and terminate them. For example, this command. The L flag is for the long format to display the kill command used for each process is killed. We can see that it used SIGTERM, which terminated them gracefully. The F flag, it looks for the provided string in the command lines of running processes. In some cases, when a script is running, its process name may not contain the name of the script, so you won't find it using pkill without the F flag. This is often the case with scripts executed by an interpreter, as the process name is the name of the interpreter, for example Bash or Python, and not the script name. pgrep searches the full command line, making it possible to find such scripts. I need to pay attention that terminating multiple processes at once might be dangerous as you know what processes have been terminated after the command has been run. Thus, it might be a good idea to run this command first to see what's found and then run the pkill command. Lastly, I want to show you how to look up processes you don't know much about. Say you want to list all processes across all terminals. This is where you can use the process status command or simply ps. Running ps with no options shows the processes started in the current terminal. Sometimes you need to find a process that has not been run from a terminal session. For example, your browser process can be such a process. For that, you'd use ps aux. The output is quite bloated and hard to read, but with a bit of sorting you can make sense of it to find the process that, for example, consumes the most memory. Still, it's quite a few lines here, so we can use the head command from the previous video to show only the first 3 lines. I'll leave it to you to learn what A, U, and X mean, since you already know that almost all answers can be found using the man command. Although PS is a mighty tool, It's static and only shows you a snapshot of all the processes at the moment you run the command. If you want to see everything in action, you can use top. Top might be CPU consuming, so don't be surprised to see it among the first. Top is a complicated piece of software, and we'll get to it in another lesson, but now you at least need to know how to open the help page. You can do it by pressing the question mark key. And to quit top, you can press Q. That's it for now. Thank you for watching and see you next time.